Hey all, this is the Unit 6 study guide for the test that is on March 13th. A couple things to note that this is a no graphing calculator test. There's no calculator at all on this test, no calculator needed. Normal stuff, the delta, um, turn this in for 10%. Ignore this quiz thing here, the quiz is not part of the grade. Okay. Um, and study checklist, you guys know the rules. Study music, if you're looking for some good study music, um, my recommendation this test is Beethoven's third, oh my God, third symphony. Good one, good one. Okay. Um, all right, normal stuff. It says pizza office hours here. I don't know if that'll be pizza office hours or I'll do donuts on Wednesday. I'll let you know on Monday what I'm gonna do there. All right, here we go. So, solving integrals flowchart. I guess like what I wanted to kind of cover here is like, okay, like how do you solve an integral? I think like there's kind of three things you want to look for. There's like you can just do it um, with integration rules. You can simplify, or you can do u sub. And so it's a question of like, okay, when do you do which one? Now u sub should be when you you see part of the integrand is the derivative of another part. And it should be like being multiplied or divided. So we'll do some problems like that in a bit. Simplify should be whenever you see like uh, sometimes when you see when you're dividing by one thing, uh, or you're like squaring, that's when you can simplify, or like you can multiply things out. And then integration rules, like I don't know, like you know it's integral. Okay. So these are like the three kinds of integrals that you're going to have. Integration rules, just like you know it. Simplify, meaning you have to divide or multiply. And then a u sub, meaning like you see part of the derivative with being multiplied or divided there. And so we'll do some problems like that in a bit. First thing to go over here is just like, okay, the integrals, the antiderivatives. You got to know these. So if you haven't yet, try and do this by yourself. But if not, I'll help you out. So just this is k, it's a constant. So this is just, let me zoom in a little bit here. This is kx plus c. This is x to the n plus 1 over n plus 1 plus c. Probably the most important one here. This is the biggest one. You see this one the most. This is just e to the x plus c. This is a to the x over ln a plus c. This is ln absolute value x plus c. This is negative cosine x plus c. This is sine x plus c, tan x plus c, negative cotangent x plus c, secant x plus c, and negative cosecant x plus c. So these are all the main integers you need to know for the test and for the AP test as well. These are the big ones. Okay. U substitution. So like I said before, you want to do U substitution when you you see you see the derivative of part of the integrand, and then multiply divide. What I mean by that is I'll use some examples here. So like for example, what if you had like x squared plus 1 um, to the third 2x, right? I see that this 2x is the derivative of that part. Okay. It doesn't have to be exactly. It's not gonna be. It's not gonna be usually the exact derivative of it, but like the same terms of the derivative. You know this. So differential equations, concept plus testing solutions. Yeah. So I mean, derivative differential equations. A big thing here. This is important. Is that if the derivative is like a number, like a constant, like 300, that's linear. Okay. If it is like a multiplication of itself, it's just proportional to itself, which is exponential. And then you have the derivative is inversely proportional. Okay. So yeah, moving on, solving differential equations by separation. The steps are once again to separate, to separate variables, anti-differentiate, solve for C if it's the particular solution, and then plug in C and solve for Y. Okay. Slope fields and graphical solutions. Honestly, these are kind of should be easy points. You just plug in coordinates into the derivative and check slopes. So I'll do a problem with that later. Okay, that's a test. That's all it is. This is what's on the test. Okay, moving on. Let's do some problems. Okay, so you're gonna get some on the test. You'll get some like relatively straightforward integrals like this, 1 over x squared. I think the most common mistake here is gonna be people jumping to like this, thinking this is ln. So I want to like make this really clear that if you have something like 1 over x or 1 over x plus 2, those are going to be ln antiderivatives, right? Because the power on the bottom here is 1, right? The power of 1, that's ln. But if the power is anything other than 1, so for example 1 over x squared, that is not ln. Okay, make this really clear. This is not the natural log. Okay, you got to convert it. So move that exponent up top to x to the negative second, and then we're going to use the power rule, the reverse power rule. So we're going to do negative 2 plus 1 is negative 1, so it would be x to the negative 1 over negative 1 plus c, which is the same as negative 1 over x plus c. But they give it to us in this form. Over here you can see negative x and negative 1 plus c. That's it. Okay, so if its power is to the first power on the bottom, it's going to be ln. But if it's anything other than the first power, you got to do the reverse power rule. Bring that exponent to the top, and then into your differential from there. Okay, 2. So we have integral x squared plus 1 quantity squared. So you I guess are, if we think about our flow chart or our options here, you have, well, integration rules. Well, I don't know the integral of that, and so then I'm between simplify or u sub. The thing about u sub here is I don't see the derivative of this being multiplied. So, like I don't see a 2x over here or anything x. So I can't use u sub for that reason, right? If I can take the derivative of this and it cancels the remaining x's out, you're good. But actually, if you take the derivative of this, you're going to be left over with an x. So you're going to want to simplify this one. So we know we can square it. We're going to square this. So I'll do box method, x squared plus 1, x squared plus 1, little box. It'll be x to the fourth, x squared, 1. So it's x to the fourth plus 2x squared plus 1. You are not done at this point. I've seen people think they're done here. No, now you integrate this. So now you're going to anti-differentiate that. This is equivalent to this. We anti-differentiate x to the 5th over 5 plus 2x to the 3rd over 3 plus x plus c. That's just a reverse power rule. So the answer is E. Commonly missed quiz question. Yes, so this is on the quiz, and a lot of people struggle with this question. It's also a very common AP question to get sort of a setup for U substitution, but without actually doing it. So one thing you want to do when you start converting this into a U is that you're going to have to square root. You're going to have to plug in the 4 and the 1 into that. So you're going to have to do the square root of 4 and the square root of 1 in there. So that becomes a 2 and a 1 as a bound. So already I know it has to be either D or C from that. Okay. Then the question, okay, well, is it 2 times it or is it 1/2? Well, to figure that out, we know that U is root x. So we need to find du. Du is the derivative of root x is 1 over 2 root x. Right, you should know that. Otherwise, you could do you could do x to 1/2, and it becomes x to negative 1/2 over 1/2, and you get 1 over 2 root x is what you come up with. Okay, so that's what's going on. But you should memorize that because that's just such a common one. Memorize root x is 1 over 2 root x dx. And so when we get dx alone, we don't divide by 2 root x. You're going to actually multiply by 2 root x to get this out of there. This is a mistake that I saw, right? So you multiply by 2 root x on both sides, right? So then this cancels with this, and you have 2 root x du equals dx. Now, when you plug it into the equation here, that I'll write it out. It's going to be e to the u over root x 2 root x dx. Sorry, du. And what's going to happen is this root x and this root x will cancel, and the 2 comes out front, right? So the 2 would just come out front. So that's why it's 2, okay? Because when you take the derivative, that 2 root x ends up in the denominator, so you actually have to multiply to get it over here. The root x is canceled, that 2 is still on the top, it comes out front, that's why it's 2 root 1 to 2, e to the u du, okay? Moving on, number 4. Okay, 4 and we got a couple challenging ones to start us off, but then it gets easier later on. Yeah, this is a problem I like a lot. So this is solving for k. So you're actually given what this definite integral equals. You know this definite integral equals this value, but you want to find that k. And you know k is greater than 0. So you're going to do a u sub, because in order to integrate this, you have to do a u sub. So our u, because I see that the derivative of the bottom is the top, u equals x squared plus 4. So du equals 2x dx. And so dx equals du over 2x. Then when I sub it in, I'm going to get integral from 0. So now I'm going to plug in a 0 here. 0 plus 4 is 4, because I'm plugging in 0 into my u. And k into that is going to be k squared plus 4. And then what's going to happen is that x and the x are going to cancel. I'll write it up. It's going to be x over u du over 2x. And what's going to happen is this x here is going to cancel with this x here, and you're just going to have 1/2, because that 2 is going to come out front, integral 4 to k squared plus 4, 1 over u du. When you integrate that, you take the antiderivative, you're going to get 1/2 ln u from 4 to k squared plus 4. Okay? Follow me so far? Alright, so now we'll do the difference quotient. So we're going to have 1/2 and then parentheses ln. Now I'm going to plug that in for u. k squared plus 4 minus ln 4. And at this point, I know that this is supposed to equal 1/2 ln 4. Like I know this must equal 1/2 ln 4. So the half and the half, they cancel out, right? If I'm solving for ln 4 right now, the half and the half are going to cancel. And you can actually do this kind of intuitively. Okay, look, think about this. ln of something minus ln of 4 must equal ln of 4. So this must be here, this must be 2 ln 4 in order for this to be ln 4, right? That makes sense, right? So, because in order, if I'm subtracting ln 4, the only way to do that is if this is 2 ln 4, right? 2 ln 4 minus ln 4 must be ln 4. And then using the properties of logarithms, that means that this must be ln 8. Does that make sense? Because when you subtract logarithms, you divide their terms. I know this must be ln 8. Sorry, ln 16. This must be ln 16. Okay. I know that because, look, ln, this must be, in order to get ln 4, this must be ln 16, because ln 16 minus ln 4 equals ln 16 over 4, which matches ln 4. This property is logarithm. So if that's 16, that means that k squared plus 4 must equal 16, which means that k squared must equal 12, which means that k must equal root 12. So if that seemed like a hard problem to you, it is. This is a hard problem. I would say, like, again, if you're like, this is the kind of problem that you would want to try and get if you were trying to get a 5, right? This is like the 5 level problem, the hardest kind of problem you're going to get on the test, because there's a lot of steps here. So if this was like a little bit of you're lost on this, like you didn't really follow that, like don't worry too much. Seriously, like don't spend all your time on this. Keep moving on. This is like something I want to show you so you're prepared for it, but like don't freak out about not understanding this problem. Okay. See me in office hours if you're still confused. Okay. Commonly missed quiz question. All right, let's do this one. So this was also commonly missed. It's a U sub, but it's with trig. Your U here is going to be 1 plus sine theta, because its derivative is cosine theta and it's inside the function. The du then is going to be cosine theta d theta, and so du over cosine theta equals d theta. And theta is just like x. Just want to make sure that's clear. D theta is just like x. So when you plug this in, we're gonna plug this into our u. So 1 plus sine 0. Well, sine 0 is just 0, so that's just 1. Sine pi over 2 is 1, so this is 1 plus 1 is 2 up top. And then it's going to be cosine theta over root u du over cosine theta. So the cosine thetas will cancel like that. And then we'll have integral 1 to 2, 1 over root u du, which then goes to integral 1 to 2 u to the negative 1/2 du, which then becomes u to the 1/2 over 1/2 from 1 to 2, which then becomes 2 root u from 1 to 2. Okay, so you have, when you plug this in, you're going to get 2, and then root 2 minus 1. Okay, and so that's the answer. 2, that's D, 2 root 2 minus 1. Okay, so your u is 1 plus sine theta. Take the du, you get du over cosine theta equals d theta. Plug the bounds into u, cancel out the cosines, get 1 over root u, convert that exponent, add 1, divide, to get 2 root 2, 2 root u, 1 to 2, and you plug it in. Okay, commonly missed question, that was D. Which of the following integrals has the same value as integral 0 to 4 x e to the x squared dx? Okay, so we're going to choose a u here. The u that we're going to choose is actually going to be x squared, because the x squared, the derivative of x squared is x, so I want to choose that one. Okay, so u equals x squared, and then we'll take the derivative, du equals 2x dx, du over 2x equals dx. Okay, then we plug it in. My u is x squared, so it's going to be integral 0 to 16 x e to the u, and then du over 2x. So these x's are going to cancel here, cancels. So it just, I end up with 1 over 2 integral 0 to 16 e to the u du, and I see that right here, it's b. Okay, clear on that one? Always check the bounds, guys. Don't forget the bounds, because if you didn't check the bounds, you might have chosen A. Make sure you always plug in the bounds into the u. Okay, moving on. We got another u sub here. So again, I see that the outside is the derivative of the inside here, so that's my u. U is 4 minus x squared du equals negative 2x dx, du over negative 2x equals dx. Let's plug it in. We're going to get integral x root u x root u, and then du over negative 2x. These x's are going to cancel here. And so I will have a negative 1/2 out front, because I'm bringing that negative 2 out front. And we'll rewrite this as u to the 1/2. No, I won't. I'll leave it as root u, because I know the derivative of that. Sorry, no. Sorry, cut this. I do want to convert it. Negative 1/2 integral u to the 1/2. I was thinking of the derivative instead of the antiderivative. When we anti-differentiate this, it's going to be u to the 3/2 over 3/2 with a negative 1/2 on front, plus c. And then so you bring this up and you flip it. So it's going to be negative 1/2 times 2/3 times u to the 3rd plus c. So it's going to be negative 2u to the 3rd over 6 plus c, which is negative 1 over 3. Sorry, it's 3/2. U to the 3/2 plus c. And then at this point, we have to plug the u back in. So our u originally was 4 minus x squared. So we're going to plug that back in here. We're going to get negative 4 minus x squared to the all to the 3/2. Which I'll get home to in a second. No. Sorry. This is a squared here. Again, I apologize. Let me rewrite this. I'm plugging in right now u. My u is 4 minus x squared. I am plugging that into this u right here. Sorry, guys. Negative 4 minus x squared, close it, all to the 3/2 over 3 plus c. That is the answer. Okay, so we go back up. Do I look for that? Negative, there it is, right? Negative, no, this one, e. Negative 4 minus x squared, all 3/2 over 3 plus c. That's what I got. Okay. All right, 8. It's a good one. I like 8 a lot because it's a kind of different kind of problem than we've seen so far. So you might be thinking, okay, think about the rules. We can simplify this, right? Technically, it would be horrible, but you could multiply this out 5 times. You're not going to spend your time doing that. You might think u sub, and yes, you could do a u sub here, because if you make your u 3x plus 1, the derivative of that is just 3, so I don't have any x's here, so I could do a u sub. But the way that I recommend doing this is if the derivative of the inside is just a constant, you can just do this by hand. What I want you to think of, since this is just an x, then this is only relevant when it's just an x. Okay, it's important. Think about something to the fifth power. What's the antiderivative of something to the fifth power? Well, the antiderivative of something to the fifth power is just itself to the sixth power over 6, right? Okay, well, what was inside there? Well, it was 3x plus 1. So if I then take the derivative of this right now, I'm going to get 3x plus 1 to the fifth, because the 6's will cancel, but then I'll have to multiply by the 3 on the inside. Do you see that? Because it's a chain rule. So to undo that multiplying of the 3, you also have to multiply this by 1/3, because that undoes that 3 there. So the answer is 3x plus 1 to the 6th over 18 plus c. So it's A. Okay. So you could, if you were like, I don't get that, you can do a u sub here. You can just make you could do or u equals 3x plus 1, and then solve that and use that, right? Does that make sense? Okay. So again, key here thing, guys, is that if you take, once you get your answer for your integral, its derivative is the integrand. When you take the derivative of this, I should get this always. Derivative of this is this. Okay, next one. 8. Yeah, 8. You are going to want to refer to my simplification guide. If you look at the front page at the bottom, you want to simplify if you are ever dividing by one term or squaring, or you can multiply things out. Notice here that I'm dividing by one term. Where's the problem here? Yeah, you're dividing by one term. So rather than doing a u sub, and in fact a u sub is not going to work here, because you would see if you did it, it would not come out right. You actually want to just divide this. This is the same as the integral from x plus 5 over x squared dx. And so we can convert this to integral x plus 5x and negative 2 dx. That is x squared over 2 plus 5x and negative 1 over negative 1 plus c. Okay, it's just reverse power rule. Then I can just rewrite this. This is going to be x squared over 2 minus 5 over x plus c. So it is c. Okay. 9. X over root x squared plus 9. Just more practices. More practice is the same thing, guys. It's a u sub, but it's a definite integral. U is x squared plus 9. Du equals 2x dx. So du over 2x equals dx. Let's plug it in. It's going to be integral. Don't forget to plug in the bounds. 9 and 25. X over root u du over 2x. Cancel the x's out, and then it's going to be 1/2, 9 to 25. I'm going to convert this u to the negative 1/2 du. Integrate and you differentiate. It's going to be 2 root u. Okay, because when I add 1, we get u to the 1/2, right? U to the 1/2 over 1/2, which becomes 2 root u. 1/2 out front, which is just a 1. So it's actually just going to be root u from 9 to 25. So it's going to be root 25 minus root 9, which is 5 minus 3, which is 2. Okay. Using u sub, what is this equivalent to? So same thing, guys, like plug in the bounds into this. So it is gonna be 1 to 9, so we can cancel those out because it's interval 1 to 9. When you take the derivative, oh, this is interesting. Yeah, this is not a straightforward problem. So it's gonna be e root u over here, but then we wanna rewrite that 3x in terms of u. So if your u is x minus 1 and that's an x, think about this. We want to write that in terms of u. Okay, so if you put so x equals u minus 1. Look at that. If I solve for x here, if u equals x minus 1, then u plus 1 equals x. So right there, instead of putting just a straight u here or things canceling out, I'm going to replace that x with u plus 1. It's going to be 3u plus 1 root u du. Because the derivative of du is just dx. Okay, this is a weird problem. This is a funny problem. There's nothing that gets canceled here. You are just subbing in the u for both the x and the x minus 1 that's in there. This is an interesting problem. Okay, 11. Antiderivative of 2 to the x. This is just straight from your notes. Okay, this is a to the x. Go back to here. Make sure you know this one. A to the x dx, which is a to the x over ln a. So here I would know this is just going to be 2 to the x over ln 2 plus c. That's it. So it's c. All right, same thing here. This is a gimme. How do you get secant x tan x? That's just secant x plus c. Okay. 13, e to the x plus e. Nothing, no u sub here. The antiderivative of e to the x is just e to the x. The antiderivative of e is actually just ex. And again, think of like e as if it was like it's similar to like a 2. Sorry, similar to a 2. So you take the antiderivative of 2, you get 2x. So the antiderivative of e is just ex. Okay, that's it. So that is e. 14. Okay, this is a cool one, which I haven't gone over with you much. This is not a u sub because the derivative of this doesn't match that exactly, and like as in the 2x does become an x, right? Like a 2x and a 5x, like I can use that to cancel the x out. But then I'm going to get this other derivative from that root x, which I don't want. So what you're actually going to do here is you're going to multiply things out. So you can simplify this by rewriting that as x to the 1/2 minus x squared, and we're just going to multiply this straight through. So 5x times x to 1/2 is actually 5x to the 3/2, because there's like a little 1 up top here, so you're doing 1 plus a half, that's 3/2, minus 5x to the third. Then we'll differentiate this. We're going to get 5x to the 5/2 divided by 5/2 minus 5x to the 4th over 4 plus c. And so this can flip it and multiply. It's going to be 2 over 5 times 5x to the 5 halves minus 5x to the 4th over 4. And so those 5's cancel, so it'll just be a 2 on top. So there it is, 2x to the 5 halves minus 5x to the 4th over 4 or plus c. Okay. Let me write that clearly here. This is going to become 2x to the 5 halves minus 5x to the 4th over 4 plus c. Okay. Another u sub. Just in case you didn't get it in all the other ones, one more. U is x to the third minus 1. Du is 3x squared dx. Du over 3x squared equals dx. Plug it in. Integral x squared u to the 10th du over 3x squared. X squareds cancel. Then I just have 1 over 3 integral u to the 10th du. Anti-differentiate. That's u to the 11th over 11. 1 over 3 plus c. Plug in that u back in. We're going to get over 33, because 3 times 11 is 33. And then it's going to be x to the third minus 1 to the 11th plus c. Okay, that's it. D. Yep, okay, moving on. Integral 0 to 5, 5 minus 6 over 5. Okay, this is the same as, again, since I'm dividing by one term, I can just divide top and bottom by that term. This is integral 0 to 5 of root 1 minus x over 5, or 1/5 x. And so, since this is like the other one, since the derivative of this does not have x in it, like the power is 1. It's kind of similar to this problem right here. Yeah, it's similar to this problem. 3x plus 1 right here, the power is 5. Sorry, the power is 1. It's similar to that. The power here is also 1. So I don't need to worry about u sub because there's nothing to cancel out. So you can, like with the other one, you can kind of think of it like, oh, this is kind of like saying something to the 1/2 power, right? So if you integrate something to the 1/2 power, you're going to get something to the 3/2 power over 3/2. And so in this case, what is the thing that's in there? Well, it's 1 minus x to the 5th. But the thing is, when I take the derivative of this right here, I'm going to have to multiply by negative 1/5. So to counter out the negative 1/5, I got to multiply by negative 5. So it's going to be negative 5 out front. So when we simplify here, you're going to get that 2/3 is going to come up. So it's going to be 2 over 3 times negative 5, 1 minus x to the x over 5 to the 3/2, which is, I need space. This is going to be negative 10, 1 minus x over 5 to the 3/2 over 3 from, and now I'll plug in the bounds, so, oh, I don't need to change my bounds because I didn't ever do a u sub. So it's going to be negative 10, and then when I plug in a 5 here, that's just going to be 0, so it's just 0, so this is over, because that's just, oh, let me bring this up, this is just 0, minus negative 10 times one, because 1 to 3/2 is just 1. When I plug in a 0 there, when I plug in a 0 here, I get 1. over 3, so it's just negative 10 over 3 is the answer. Oh, but it's a double negative, so it's positive. Yeah, it's B. Okay. Moving on. 17. 100 e to the x over 4. It's kind of similar to the other ones. I don't need to do a u sub here because I can work this out intuitively. Whenever you take the antiderivative of e to something's power, it's gonna be itself. Like it's gonna be 100 e to the x over 4. And then just take the derivative of this and see what happens. Well, when you take the derivative of this, you're gonna get 100 e to the x over 4 times the derivative of x over 4, which is 1/4. So you're gonna get 25 here. So in order to counter that, I gotta multiply this by 4 to counteract that 1/4 right here. So the answer is 400 e to the x over 4 from 0 to 4. Now you plug it in, you're going to get 400 e to the 1 minus 1. See? Alright. We're done with u sub, thank the Lord. We're done with integration. We're done with it. Okay, we're continuing. 18. For what value of k, if any, will k e to the negative 2x plus 4 cosine 3x be a solution to the differential equation y double prime plus 9y equals 26 e to the negative 2x? Okay, so to solve this one, you may recall, we did this in class. You are plugging in this into this and solving for k. So I have y, so I know what to put there. But y double prime, I need that. So if we write this, y equals k e to the negative 2x plus 4 cosine 3x. Y prime is going to be negative 2k e to the negative 2x. Right, all I did there was, that was just a chain rule going on. Plus negative 12 sine 3x. Chain rule. Okay. Because e, the k stays, the e stays, but then you have to multiply by its coefficient up here because it's chain rule. Root of that is negative 2, that's where that comes down. And then same thing here, 3 times 4 is 12, and then cosine is negative sign, so that's why it's negative. Take the y double prime, we're going to get 4k e to the negative 2x, derivative sign is just cosine, minus 36 sine, cosine 3x. Now we'll sub that into this formula right here. So I'm going to get that for, okay, I need some space here, right? I'm going to get 4k e to the negative 2x minus 36 cosine 3x plus, I'm reading this up here, plus 9 times k e to the negative 2x plus 4 cosine 3x equals 26 e to the negative 2x. Okay. I know this looks kind of bad, but it's not as bad as it looks. See, I see something that's going to happen here. See this 9 times the 4 is going to create, it's going to make that a 36. So we can cancel that out and cancel that out there. And then with the 9 on this, that is going to go together. So we are going to get 13 with these two together. Those come together. And that's going to be, sorry, not 14, 13. 13k e to the negative 2x equals 26k e to the negative 2x. Goal is to get that k alone, right? So we're just going to divide both sides by 13 e to the negative 2x, divide by 13 e to the negative 2x, and we're going to get k equals 2. Okay? K is 2, after all that. Which is the following solution to the differential equation? dy dx equals e to the 2x plus 2y. Okay, so you can start just by testing them. So do you test A? Well, dy dx, that is, I'm going to show this like a little, I'm going to show this very clearly. So if my option was option 1, y, then I need y equals e to the 2x. I need y prime, which is 2e to the 2x, and then I'm going to plug that in here. So remember, this is just dy dx. It's the same thing. So it's going to be 2e to the 2x equals e to the 2x plus 2e to the 2x. That is not true, because you're going to get 2e to the 2x equals 3e to the 2x. So this is not true. No. So A is not it. B, I'm going to skip B because just because like A didn't work, there's no reason that B should. So then I believe it's going to be either C or D. So let's test one of those. So it's just a C potentially. Let's try C. Sorry, I'm just thinking about B for a second here. So I made that negative. Then the derivative would just be negative that, which means you plug it in, you're going to get negative 2e equals e minus 2, which is not true. So yeah, B does not work. C, x e to the 2x. So I'm thinking about this one now. Okay, let's try it. So I need that, and I also need dy dx, which is product rule lefty right, x 2x e to the 2x plus right d left, just e to the 2x. Alright, so when I plug this one in, I'll get 2x e to the 2x plus e to the 2x equals e to the 2x plus x e to the 2x. Sorry, 2x e to the 2x. Hey, this is right. This is true. This is true. So it is C. Because this is true. Okay, this is product rule right here, by the way. So it's clear. Alright. Let's see. Alright. 20. A jogger runs along a straight track. The jogger's position is given by the function p of t, where t is measured in minutes since the start of the run. During the first minute of the run, a jogger's acceleration is proportional to the square root of time since the start of the run. Which of the following is a differential equation that describes a relationship where k is a positive constant? Okay, so key parts of this question. So this is position. P of t is position. That's important. Acceleration is really important. And for the word proportional is really important to the square root of time. Okay, so if it's proportional to the square root of time, so proportional means multiply. So which one is the square root of time? This is the square root of time, right? So it's going to be either C or A, right? Now, C or A, I have dp dt or d squared p over dt squared. Well, which one is acceleration, right? Which one's acceleration? This is position. This right here, this is velocity. And this is acceleration. So it must be C. Alright, well, we're getting there. The rate at which quantity m of a radioactive substance decays is proportional to the amount of substance given at that time. Which of the following is a differential equation that could describe this relationship? Okay, so it's decaying. All right, decay is important here. So it's decaying, like you're losing stuff. So this must be negative slope. Like how could that be positive? I must be losing, right? So it must be negative. So we can eliminate C and D there. And it says proportional. Again, proportional means multiply to the substance to the amount of the substance present at that time. So I mean M is substance, so it must be B. Because it's not proportional to time squared, it's proportional to substance. Okay? 22. E to the 3x minus 5x plus 7 is a solution to which of the following differential equations? Okay, so to do this, we have to do it. So we need y prime and we need y double prime. So let's write from the start. Y equals e to 3x minus 5x plus 7. So y prime is 3e to 3x minus 5, and y double prime equals 9e to the 3x. Okay. Then what I would do is I would just like, you can kind of look to eyeball it, but I am just going to plug it in. So but I kind of know where to start a little bit here because that's 9. So to make this 0, I have to subtract 9e to 3x here. So that means it must be like a or b. And then it's okay, it's gonna be plus 15 or minus 15. Well, because that's a minus 5 there, right? Ooh, but it's a double negative. I know it's a. So but from just like from looking at these, I know it's a. And I'll prove it to you. You could just test it through all of them, but I know it's gonna be a. So we're gonna have 9e to the 3x minus parentheses 3e to 3x minus 5 minus 15 equals 0. This is true because so there's a 3 in front here. There's gonna be 9e to 3x minus 9e to the 3x plus 15 minus 15 equals 0. Cancel, 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 cancel. It's true. So it must be A. Okay? Alright, some differential equations now. If, we're getting there. If dy dx equals secant squared x and y equals 5 when x equals 0, let's see if I can just, there we go. Then y equals what? Okay, so let's just rewrite this out. Dy dx equals y secant squared x. Find y. So separation of variables, we're going to get dy over y equals secant squared x dx. All I did there was I divided by y, multiplied by dx, take the integral. We're going to get ln y equals tan x plus c. Then alright, I'm going to do this the way Delta does it. So to solve for c, we're going to get ln 5 equals tan 0 is just 0. So ln 5 is c. So we'll go back to the original. We're going to get ln y equals tan x plus ln 5. And we're going to exponentiate. We get y equals e to the tan x plus ln 5. And that is the same thing as, this is important, see this ln 5 right here? If you have like a plus ln 5 in the exponent of e, that can come down in front as a 5. So this is y equals 5e to the tan x. That is C. Okay, So separation of variables, anti-differentiate, solve for c, plug it in, and then this is like is a rule where if you have a plus 10 ln 5 in the exponent here, that can come down as a 5 in front. So that's why it is c. Okay. I mean, you could eliminate. I mean, there's no way it's a or b, right? There's no way it's d. Maybe you would like guess, oh, could it be e? But no, it's c. Okay. Some slope fields now. Slope fields. Um, so which one of these is a slope field? Well, let's have a look here. So something you want to look for when you look at slope fields is like any patterns here. So like something I noticed right here is like it's 0 all around 4, which means when I plug in a 4, I should get a 0. That's a good thing to check first. So let's make sure. Yeah, I'm going to get 0 whenever I plug in a 4. I also noticed that um, all the rows are horizontal. What that means is that my differential equation does not depend on x. So because no matter what x is, it's always the same slope. So it cannot have x in it. So I can eliminate both a and c for that reason. It cannot be either of those. And so it's between b and d now. Is it y squared or is it just y in front? Well, I can pick like two coordinates here. So this is 2, right? So like if we look at like right here, this is 4 down, and they go 1, 2, 3, 4 up right here. 1, 2, 3, 4, 1, 2, 3, 4. Yeah. If we look at these, um, they should be if it was y, right? So let's plug it in. What are the coordinates here? This is like um, this is roughly like what 1, or we'll do these two. 1, 2, like an easy coordinate, like 1, 2, and 1, -2. So we try x equals 1, y equals 2, and x equals 1, and y equals -2. I plug them in. I'm going to get um, 2 times 2 over 4, which is 1. And this one I'm going to get uh, -2 times 6 over 4, which is -12 over 4, which is -3. And so if it was b, if I change my y positive and negative, the sign should flip, right? Because this would indicate that it would be positive here and negative here. But since they're both positive, like y equals 2, y equals 1 and y equals -1, that indicates that it must be d. Because when I square it, that'll make it positive the whole time. Okay. 25. Which of the following slope field for x squared plus y squared? So a good place to start is just by like plugging it in. So like pick a point, any point you want. So I'm picking something easy like x equals 1, y equals 1. So that just means my slope should be 2. So I should make sure at that point I should have a slope of 2. So it's having some positive slope here. Um, also some sort of positive slope here, but here I have a negative slope. So a is out based on that because at that coordinate 1, 1 I have a negative slope, so it cannot be a. It could potentially be CBD right now. Let's pick something else here. So something I notice is if you look at uh, C and D, all of their vertical axis here, the x-axis, they're all horizontal, which would indicate that it should be always 0. But that's not true because if x is 0, sure, but if y goes up, I should have an increasing slope, right? And as y goes down, I should also have an increasing slope. So because of this like weird like zeros in the middle, these are out. It has to be. Okay. So you're looking for patterns. You're looking for, okay, like if y is increasing, so should the slope, because it's based on x squared plus y squared. So why is that not increasing here? So that can't work. Same with this one. That one is the one it's got to be. Last page. All right, here we go. 26. What is the general solution to the equation dy dx equals root y minus root y sine x for y greater than 0? All right, here we go. Dy dx equals root y minus root y sine x. How do you do this? You got to get root y with root y sine and sine x with the dx. So we actually have to factor out the root y here. So we're going to rewrite it as root y 1 minus sine x, so we can separate those variables. And now I can move things around. So now I can get dy over root y equals 1 over sine x, 1 minus sine x dx. Okay. All I did there, so I took out the root y, then I divided by root y, and divided by root y here, and then I multiplied by dx, and I multiplied by dx here. So like those canceled and those canceled, so I left with this. Now in differentiate, you got y to the negative 1/2 dy, so which is going to become y to the 1/2 over 1/2, which is the same as, I'll move it back up here, 2 root y equals x plus cosine x plus c. Okay, and it just wants a general solution, so I don't need to do a lot more than this. I'm going to divide everything by 2. So you're going to get root y equals all this, x plus cosine x plus c over 2, and then we're just going to square that. So we're going to get y equals x plus cosine x plus c over 2 quantity squared. Do I see that? Yep. Nope. Let me look. Oh, yeah, I think it simplified it to d and took that 1/2 out at the bottom and wrote it as a 1/4 in the front. That's what I think they did there. Okay, so d. Okay. 27, another differential equation, same thing. It's going to be dy over y minus 2 equals x minus 2 dx. When you separate it, so it's going to be ln y minus 2 equals x squared over 2 minus 2x plus c. When you plug in a 4, you should get a 5, so it's going to be ln 3 equals 8 minus 8 plus c, so ln 3 equals c. You plug it back in, and we're going to get ln y minus 2 equals x squared over 2 minus 2x plus ln 3. You're going to exponentiate that. You're going to get y minus 2 equals x squared over, or sorry, e to the x squared over 2 minus 2x plus ln 3, which, reminder what I just told you, this ln 3 can come down as a 3 right here. So you get y equals 3e to the x squared over 2 minus 2x plus 2. Okay. Yeah, that'll be B. Okay, 28. The function y equals f(x) satisfies the differential equation dy dx equals 2xy with the initial condition f of 0 is 5. What's the value of f of 2? Okay, so here we go. Dy dx equals 2xy. So we're going to get dy over y equals 2x dx. Ln y equals x squared plus c. And we were told that f of 0 is 5. So ln 5 equals 0 plus c. So c is ln 5. So we'll go back to there. Ln y equals x squared plus ln 5. So therefore y, when you exponentiate, right, y equals e to do 5, oh no, I'll write it probably, e to the x squared plus ln 5, which is the same as y equals 5e to the x squared. Because again, this ln 5 can move down the front as a 5. Okay. So we're not done yet. This is what the value of f of 2. So when you plug in a 2 here, I'll get y equals 5e to the 4th. So it's D. Alright. 28. 28, I'll go over it. A student attempted to solve the differential equation. In which step, if any, does an error first appear? So they separate the variables, and that part looks good. Then they anti-differentiate, and that part looks good. Then what did they do here? So let me explain this to you. So from here to 2 to 3, they're doing it slightly different than how Delta does it. What they're doing is they're at ln y equals x squared over 2 plus c. And they're exponentiating right now. So they're saying, okay, y equals e to the x squared over 2 plus c. But here's the problem. They didn't put that plus c in the exponent. I know it's kind of hard to see, but they wrote, this is what they wrote, y equals e to the x squared over 2, but then plus c down here. What this then simplifies to is y equals c e to the x squared over 2, which is good, but this one's wrong. So that was their mistake. Their mistake is in step 3. Yeah. Okay. All right, that is the multiple choice. Done. Okay, we're back here. All right, we're back here with the FRQs. So there's only one kind of FRQ on the test. Just heads up, there will only be one kind of FRQ problem, and this is the kind that you'll see. It is a differential equation problem. Let's do the 22 ones. This is the question from the 2022 exam number 5. Consider the differential equation dy dx is 1/2 sine pi over 2x root y plus 7. Let y equals f of x be the particular solution to the differential equation with the initial condition 1, 2. The function f is defined for all real numbers. A portion of the subfield for the differential equation is given below. Sketch the solution curve through the point 1, 2. So guys, this should be an easy point. Like this should be a gimme. And because all you have to do, you go to that point that's highlighted for you, and you're just gonna follow. Like you can think of connect the dots. You can think of it being like water, whatever you want to say. You're just gonna follow those tangent lines. Okay, and it'll look something like that. And going the other way, we're going to continue down and following those dots, up and down, just like that. Okay. Maybe this one could have been a little bit higher, but this is fine, right? The important part is, and I'm going to have the solution guide next to me just to like go over it. If you look at the solution curve that's in your practice test, you must pass 1, 2, extend reasonably close to left and right edges of the square, and have no obvious conflicts with the given slopes. Only portions of the solution curve with the given slope field are considered. The solution curve must indicate that it's above 0 for all points in the curve. All that means is like this should never go negative. All maximum minimum points must occur at horizontal line segments in the slope field. So what that's saying is like you shouldn't be like the maximum has to happen when it's horizontal, like here and here. So if we look at ours, even though mine doesn't go as high, it still would be fine because that does happen at that point. Okay, good. So that should be a free point. Everyone should get that point, no doubt about it. B, write an equation to the tangent line to the solution in the curve part A at the point 1, 2. So this is in the delta. I think it's 6.3 or 6.4. Equation of the tangent line. So again, whenever you're in the AP test and you see equation for the line tangent, you just write the formula. Y minus y1 equals mx minus x1. And look, it gives us the coordinates here. So my x1 is 1, my y1 is 2, and then my m, I'm going to get that by plugging these two values into my derivative. So I'm going to plug them in there. So I'm going to get 1/2 sine pi over 2 times 1 because x is 1 times root 9 because 2 plus 7 is 9. Now sine pi over 2 is 1, so this is 1 times 3, which is 3, and then times 1/2, we have 3 over 2. M is 3 over 2. So I'm just going to plug in everything into the formula. We're going to have y minus 2 equals 3/2 x minus 1. Okay, then that's 1 point right there. So I'm going to grade this right here. That's 1 point. This is 1 point right here. And then we have to plug in the 0.8. So we're going to put 0.8 into there. So we're going to get y minus 2 equals 3/2 0.8 minus 1. And then we're going to do plus 2 and a plus 2. So we will get y equals 2 plus 3 over 2, 0.8 minus 1. This is actually fine. You can leave it like this because once again, like once you get in a point where I can put this in the calculator and I'll get the right answer, you're done. If you want to go further, we can. You would get, so that's negative 0.2, right? That's negative 0.2. So negative 0.2, that's negative 2/10. So I'm getting negative 3/10. So this is 1.7. Yeah, this is 1.7. If you did it, if you worked it out, longhand, that is 1.7. Okay. So again, this is fine. So what you don't want to do is write this and then make a mistake in simplification. So if you're like, okay, I'm just gonna leave it right here, this is fine. Just leave it like that. Okay. Let's look at the answer key just to check it over. So they got the derivative, 3 over 2 like we did. They wrote the equation, that's 1 point. to plug in the 0.8 just like we did, and then go 1.7. But this is fine right here. Okay, one thing actually I would specify is I'm writing y equals this. I should instead write f of 0.8 is approximately 1.7. That I'm not sure if this this y equals 1.7 would count. Make sure you write it as f of 0.8 because that's what it's telling me to find here, right? That. Okay. Let's go back here. So tangent line can be represented in any form. Okay. This is not relevant. And then if you only wrote this, you would only get the second point for the approximation. You have to write the original equation. That's what that's saying for that part. Okay, C. It is known that the second derivative is positive from -1 to 1. Is the approximation part B an overestimate or an underestimate for f of 0.8 to give you a reasonable answer? So you can always like remind yourself of this by drawing it. So if it's concave up, you have to know that's concave up. But if it's concave up, you have a U like that. So you think about approximating a tangent line here like that. What do you notice? The line is under the curve. Okay, so since f double prime of x is greater than 0, it is concave up for -1 to 1. Therefore, the approximation for f of 0.8 is an underestimate. Okay, and if we look at the answer key there, it's the same thing. So because it's greater than 0, it's concave up. Tangent line lies below the graph, as we drew out here. The drawing is not your evidence. That's not like justification. You have to say it. The tangent line lies below the graph at x equals 0.8, and the approximation is an underestimate. So must mention that it's concave up. It's important. Okay. All right. Then we're on D. So the majority of the points, that's a point there. The majority of the points come from the last question, which in this case is 5 points. So the last question is one of those delta problems from 6.4. And the way that these questions are graded is always the same. And these are always on the AP test. And so even if you don't get the final answer, you can get points. A lot of partial credit is on offer here. So always do your best. Always show your work very clearly. The steps, if you remember, for solving a differential equation by separation is you want to separate. You want to anti-differentiate. You want to solve for C. And then you want to plug in C, solve for Y. And in this case, it depends on the question, but generally separation is going to be 1 point, antiderivative is around 2 points, solving for C is a point, and then plugging back in C and solving for Y is a point. So again, even if you get the first two, you still got the majority of the points. So don't feel like, oh, I didn't get the final answer, it's over. Just do as much as you can, do it the best you can. Okay, let's do the problem. So dy dx equals 1/2 sine pi over 2x root y plus 7. So it's the same thing. You want to get the x's with the x's, the y's with the y's. So we're going to multiply by dx on the left here, and on the right, And then we're going to divide by both sides root y plus 7, and over here root y plus 7. Okay, what happens is cancels, 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 cancels. So I have dy over root y plus 7 equals 1/2 sine pi over 2x dx. Okay, plus c. No, not yet. Sorry, not plus c yet. Questions so far? Okay, so now we're going to take the antiderivative. We've done separation. We got our 1 point. Now we're going to take the antiderivative. So to take the antiderivative here, I want to convert it. So I'm going to rewrite this as y plus 7 to the negative 1/2 dy equals, this one's fine, 1/2 sine pi over 2x dx. This one, I'm going to add 1 and divide. So it's going to be y plus 7 to the 1/2 over 1/2 equals, now what's the antiderivative of sine? Well, cosine gets me negative sine, so it must be negative 1/2 cosine pi over 2 x. Now here's the thing. Because of this pi over 2 coefficient in here, right? When I take the derivative of this right now, I am going to get sine. I will get 1/2 sine pi over 2x, but I will have to multiply by pi over 2 because that's the coefficient inside this chain rule. So we have to multiply by 2 over pi to undo that. Okay, so right now this is a point right here. This is a point here. This is a point here, and this is a point here. Okay, so we've got, we had 3 points so far. We're going to clean things up a little bit. Dividing by half is the same as multiplying by 2. So I have 2 root y plus 7 equals, and then these 2's are going to cancel right here. You see that? This 2 here, just going to cancel that 2 here. So I'm going to have negative 1 over pi cosine pi over 2x plus c. Okay. Still no new points here. I just reorganized things, simplified things, but that's no new points so far. Then we need to use the initial condition. So I'm told that f of 1 is 2. So we're going to plug in our values. We're going to get 2 root 9, because 2 plus 7 is 9, equals negative 1 over pi. My x is 1. Cosine pi over 2 is 0. So that's just a 0. Plus c. So my c is just 6. C is 6. And that is a point. Okay. Gotta know those basic trig functions, guys. Gotta know the basic trig functions. Okay. Gotta know cosine pi over 2 is 0. Okay. We're on our last step. So now we know c is 6. We just go back here, and we're going to replace the c with a 6. Kind of draw a line here to show you I'm on the next stage. So we're going to do 2 root y plus 7 equals negative 1 over pi cosine pi over 2 x plus 6. We're going to just divide everything by 2, everything by 2. And then we're going to, okay, I'm gonna be neat here. Root y plus 7 equals negative 1 over pi cosine pi over 2x plus 6 over 2. Then you're gonna square both sides to undo that. So it's gonna be squared over here. And then last step is, because this square is gonna undo this right here, we're going to minus 7 here, and then minus 7 here. So your final answer is going to be y equals, big parentheses, negative 1 over pi cosine, parentheses, pi over 2x plus 6 all over 2 squared minus 7. That is it. Okay, that is the final answer. And so if you want like a neater, this is me like kind of showing all the steps. The answer key shows it like without those intermediate steps there, but you can see where the points are coming from. Separation of variables get you that 1 point. Two derivatives, that's the 2 points. Constant integration, solving for c, getting 6, that's another point. Rewriting it with a +6, and then solving for um, y, that's your last point here. The only difference between our two answers is that they divided everything by 2 here. So 6 out of 2 is 3, and that's how they got 1 over 2 pi. Okay, they just divided by 2 more cleanly than me, but both are fine. Okay, so let's look at the notes here. A response with no separation of variables is 0 out of 5. So if you don't do the first thing right, if you don't do the separation of variables, you don't get any points. A response with no constant of integration can earn at most the first 3 points. So that means is like you can earn the antiderivatives and the separation, but if you don't add the plus c and solve for it, there's no more points. You can get the 4th point only if it has earned the first point and at least one of the 2 antiderivative points. So what I'm seeing here is like if you got one of the antiderivatives wrong, you can still earn that 4th point. Special case, the incorrect separation does not earn the first point, is only eligible for the antiderivative point for cosine and is eligible for the first point, for the 4th point. Interesting. Okay. So there's different ways to get those partial credits. An eligible response earns a 4th point by correctly including the constant integration. And yeah, we did that. And then you can only get the 5th point if you've earned all the other points. That's it. So that's a differential equation problem. I mean, getting 9 points in that, guys, is like, that's really amazing, right? Getting 9 points is really, really good, right? I'm not sure what the average score was on this one, but it wasn't a lot. It wasn't that high. Maybe it was a 3, right? 3 points out of 9. But these questions are always on the test. They're always. This is last year's question, 2023. I don't think this is not number 5. This is number 3. It's a mistake, but this is one that all the kids like. I think we're not. I think this might have been the hardest FRQ problem from last year. A bottle of milk is taken out of a refrigerator and placed on a pan of hot water to be warmed. The increasing function m models the temperature of milk at time t, where m of t is in degrees Celsius, and t is the number of minutes since the bottle was placed in the pan. M satisfies the differential equation dm dt equals 1 over 4 40 minus m at time t equals 0. The temperature of the milk is 5 degrees centigrade. It can also be shown that m of t is less than 40 for all values of t. Okay, so what this is saying is we got some milk out of the fridge. So milk came out of the fridge. It's 5 degrees. And it was put on a pan of hot water, placed in a pan of hot water to be warmed. Okay, so a bottle of milk went in some water, some hot water. Okay, and it can be shown that the m of t, the temperature, is less than 40 for all values of t. So m of t never goes above 40. Okay, so the temperature should never go above 40 degrees. That's what that's saying here. Okay, so I can explain kind of what that looks like here. Where we've got soap field and we're sketching the solution curve. I cannot speak. The solution curve. So just like the other one, you start at that point that's given to you, and you're just gonna follow those curves, connect the dots, kind of. No, it's not too perfect. And then when you get to this horizontal line, it's just gonna go straight across like that. Okay, and so maybe I jumped the gun a little bit on the horizontal part, but if we look at the solution, they got something very similar, and they say it's got to pass through 0, 5. That's really important. Extend reasonably close to left and right. Yep. No obvious conflict. Only portions of the curve with the given slope are considered, and it must be below the horizontal line sequence at m equals 40. So based on that, I might not get the points because, it is below here, but because I kind of touched it at the top, it's possible they might not give me that point. So Let me redo that just to like, that's I didn't realize quite how strict that was. So let's do that again. This and more like this, it looks like. And I think like the key of why they're so strict about that is this piece of information right here. This says that the temperature is never ever going to be 40. Like it's never going to reach 40. And this, right, this is 40 right here. So if I'm reaching 40, then I'm breaking that rule. So perhaps that's why they're so strict about it. That makes sense. But good lesson there. Okay, now we've got the same question as before. Use the tangent line of the graph of m at t equals 0 to approximate m of 2, the temperature of the milk at t equals 2 minutes. So I want to know m of 2, so that's what I'm like trying to approximate. I will at some point need to fill in the blank of this. Like this is like going to be my answer. In order to find that, I need the line tangent. So you know what to do. This is the same as before. Y minus y1 equals m parentheses x minus x1. And I'm told at t equals 0. So my t is my x, right? And I know it's my x because when up here, like your x is your input, right? It's going into the function. So it's going to be, x1 is going to be 0. My y1, it doesn't say it right here, but actually says it above. At t equals 0, the temperature is 5. So this is your x1 right here. This is your y1 right here. The temperature is the y, right? You can see it here. That's this point right here. So my y1 is 5, and then my m I'm going to get by plugging these two coordinates, these two into the original right here. So my m would be, I'm going to just put in, I'm actually not going to put t in at all here, I'm just going to put in the 5. Okay, so it's going to be, I'll do it down below, dm dt at 0.5 is going to be 1/4 40 minus 5. No, there's no t there, like at all, because it's not in the differential equation. So it's going to be 35/4. Now I can write my equation. It's going to be y minus 5 equals 35/4 x. And I want to approximate 2. I'm going to plug a 2 into that. So I'm going to get y minus 5 equals 35/4 times 2. I will get from that, move the 5 over, y equals 35/4 times 2 plus 5. And again, like, you could potentially just put that as your answer and get the points. I will go ahead and simplify this. So you're going to get 35/2 plus 5. Which is 45/2. Okay, so that would be here. Again, you can put, technically, you can just put this, so you don't have to simplify it. You can just put that in there and you get the point. So a point there for that and a point for writing the equation here. Okay, let's look at the answer key. So yeah, same thing here. They got 35/4. The 35/4 was actually not for the tangent line equation, it was for the slope. So you get a point for the slope, and then you get a point for plugging it in, and they got 22.5, which is what we got. And then they wrote the sentence. Let's go to the scoring notes. The value of the slope may appear in a tangent line equation or approximation. Okay, a response of 5 plus 35/4 times 2 is the minimal response to earn both points. So that's what I was just telling you right there. This works. It's okay. It's the minimal response to earn both points. It works. It's okay. A response of 1/4 40 minus 5 earns the first points if there are subsequent errors in simplification does not earn the second points. This is what I'm saying, guys. If you mess this up and you don't simplify this correctly, you're going to lose a point. But if you just write this, you get the point. So don't simplify. Like if you're, don't do it. Just leave it as it is. In order to earn the second point, the response must earn an approximation found by using, yeah, we did that. An unsupported approximation does not earn the second point. The approximation need not to be simplified, but the response does not earn the second point if the approximation is simplified incorrectly. Exactly what I was just saying before. Don't mess it up, right? I'm not really sure what an unsupported approximation means. Yeah. Good habit though, guys, is to write, like I would write degrees here. And it would not be a bad idea to write a sentence. I don't think you have to here to get the points. It doesn't look like you have to, but it's just a good habit. The approximate temperature at T equals 2 is 45 over 2 degrees Celsius. Okay. Alright, let's wrap this up, guys. We're on C. Write an expression for d squared m dt squared in terms of m. Use d squared m dt squared to determine whether the approximation from the part B is underestimate or overestimate for the actual value m squared, or reasonable for your answer. So this question is like really similar to the other one we had earlier, but this time it doesn't give us a second derivative. We have to go find it. So if we think about what our first derivative is, dm dt equals 1/4 40 minus m. We now have to take the derivative of this again. So I'm going to simplify this because I think it makes it easier for me. So it'll be 10 minus 1/4 m, and then we're going to differentiate that. So we take the derivative of that again. Where this is going to be 0, and we're just going to get negative 1/4, and the derivative of m is just dm dt. So this might be confusing to you because why is that dm dt? Well, it's because we're differentiating with respect to t. This is implicit differentiation right now. That's why that's dm dt. So then you got to take this upper part, what is dm dt, and just sub that back into dm dt. So then this becomes negative 1/4 dm, sorry, negative 1/4 times 1/4 40 minus m, which will be negative 1/16 40 minus m. Okay, that is the second derivative. You differentiate it, derivative of m is just dm dt, and sub that back in for dm dt, and then we have our value. Okay, so the question is it concave up or is it concave down? Well, we're going to do a little sign chart, number line. So my derivative is here. So you think about the number line here. When is this positive? When is it negative? Well, 40 it's 0, right? That's the solution. So if it's above 40, it's going to be negative. If it's below 40, it's going to be positive, right? Because when I plug in a negative value here, or like a 30, for example, you get, sorry, it's the other way around. This is positive, this is negative. Because that'll be like, plug in like a 0 in there, you get 40 and then a negative. So it's negative from below 40 and positive above 40. So we could say um, since the second derivative is less than 0 for m of t less than 40, and so if you think about concave down, it'll be an over-approximation. The approximation for m of 2 is an over approximation. Okay, so let's look at the scoring guidelines. So we got that second derivative, which is 1 point. Then there was the making sure it was below 40 and overestimate. Okay, so we've got some details here about that. Just the way that you need to sub in the first derivative into that. And so on. Okay, we're going to do the last part now. D. Separation of variables. Then we're going to solve it. So this is like the big problem where you get most of the points. There's actually 4 points on offer here. So use separation variables to find an expression for m of t in a particular solution. So how do you do this? Well, I'm actually not going to simplify this anymore because the whole goal is to get m with the m. So I'm going to divide both sides by 40 minus m. And then I'm going to multiply by dt on the left and right. And so what happens is I'll get dm over 40 minus m equals 1 over 4 dt. So that's 1 point right there for the separation. We're going to anti-differentiate. This is going to be ln 40 minus m, but it's going to have to be negative because it's got a negative m on the inside, so you got to undo that with the negative up front. And this will just be 1 over 4 t plus c. So that's the point there. So again, if there's no like t over here, it's just like a constant. Just like that's how it becomes t. Okay, and we're going to solve for c. So plug in 0 and 5. 0 for t, 5 for m. It's going to be negative ln 40 minus 5 equals c. So it's just negative ln 35 equals c. Okay, so that's another point there. And then we will sub that into the original. So we'll say, come back over here, we're going to say negative ln 40 minus m equals 1/4 t minus ln 35. We're going to move that negative over. So we're going to multiply both sides by -1 right now. -1 over here. So now I'm just going to write again, ln 40 minus m equals -1/4 t plus ln 35. Then we're going to exponentiate. That'll cancel the ln. We'll get 40 minus m equals e to the negative 1/4 t plus ln 35. We'll do a switcheroo here. We'll add the m here, and then we'll just subtract that e term over to this side. So we get 40 minus e to the negative 1/4 t plus ln 35 equals m. This could be rewritten if you wanted to. This is fine, I'm sure, but it could be written. This ln 35 can come down to the front, and this could be written as 40 minus 35 e to the 1/4 t equals m. Okay, let's look at the scoring guidelines. So that separation of variables with the antiderivative, solving for c, plugging it back in, and then solving for m here. A response with no separation of variables gets you no points. You don't need to put the absolute value to get all the points. Yeah, nothing else standing out to me here. A response earns a force point only for this or the equivalent. So I assume or equivalent means our other term as well. So, okay, that is the practice test, guys. I'll see you in office hours.